Hello and welcome back to Precalculus 1, section 2.4, where we'll be working on division of polynomials. So division algorithm for polynomials is exactly the same as the division algorithm for what you know as long division. So I'm going to actually work the two side by side so we can see that the same pattern, same algorithm is used. Let's say you want to divide 12 into 4,873. Let's say that's the number you want to work with. So 12 in 4 doesn't go, but 12 in 48 goes 4 times. Now you don't have to line up this 4 up there with anything, just put it somewhere. And 4 times 12 is 48. When you multiply back, you subtract, get 0, and then you drop the next digit down. Well, 12 doesn't go into 7, so we place a 0, and then we drop the next digit down. 12 into 73 goes 6 times, and then you multiply back, which is 6 times 12 is 72, and when you subtract, you get 1. At which point you can just say R1, which means remainder is 1. If I'm to divide 4,873 by 12, I will get 406 with the remainder 1. Division of polynomials is going to work the same way. I'm going to divide, let's say, x plus 3 into x squared plus 8x minus 10. Let's say this is what I need to divide. Well, if you remember, I asked how many times 12 goes into 48 and I obtained 4. I'm going to ask a same question here. How many times x goes into x squared? And the answer is x times. Exactly. So the first thing I write is x. Now x, we know what we did when we wrote 4. You multiplied 4 times 12 to get the 48. Now you will multiply x times x is x squared plus 3x. You subtracted 48, therefore you get to subtract this one. X squared will die because x squared minus x squared is 0. And you have 8x minus 3x, which is 5x, and we drop down minus 10. So now you ask yourself how many times x goes into 5x, and the answer is positive 5 times. 5 times this is 5x, and then you have plus 15. Don't forget that you are supposed to subtract that because that's the algorithm. And now you have these guys cancel. Negative 10 minus 15 is negative 25. So as a remainder, you will say minus 25 over x plus 3. That's the remainder. So as you can see, these two methods, whether you're dividing numbers or dividing polynomials, are identical. Now, why would that be so? Guys, just realize, if you say that x is equal to 2, you got 4 plus 16 is 20 minus 10 is 10. Awesome. Look at this and be amazed. If I say that x is equal to 2, x is equal to 2. I can compute this for number 2. I get 4 plus 16 is 20 minus 10 is 10. So that number will be 10. And then I compute this at 2 and I get 5. 5 into 10 goes twice. That means that when I plug in 2 over here, this must be 2. Otherwise we're doomed. Mathematics doesn't work, we all go home. Well, look what you got. This is 7. And you plug in 2 over here, it becomes 5. And you get 2. And this is not magic. It's not magic. This is actually, guys, polynomials That's just a fancy way to write a whole bunch of numbers. So the algorithm here works in the algebra domain, but if you are to replace any one of these, well, all of these x's with the same number, well, working out this way, computing the answer, or computing the numbers and computing the answer will give you the same answer. I hope you realize that from this exercise. I mentioned exercise, so I felt like doing some. It was a 1 rep for today. Feeling good. Can't erase the rest. Final. So I hope you see the exact parallel between the two. Hopefully you see that this is exactly the same procedure. So now let's take a look at the examples that the book thinks would be good for you to practice. So here is the example. Try this one. It says x minus 3 divided into 2x cubed, no coughing, minus 3x squared minus 11x plus 7. It's buzzing. My bad. Mine does. The purple one doesn't do anything, but the gray one does. So you can. Well, I. And apparently the same battery does. So my camera is way too long. I heard here. Technically, a fracture is great.
Oh, no, it's alright. My mom was just like, okay, I'm like, yeah. I don't know, my friend just called them.
Well, because you're in class, no one knows that. Let's take a look at this division together.
I was scared too. I was like, call me.
So, this is how we work. X goes into 2x cubed. So you can literally go from your algebra and divide 2x cubed by x, where x will cancel this and you will have 2x squared. So you can do this algebra piece on the side if you are confused a little bit about how to make what goes as answers. So once I have this, we know we are supposed to multiply back. I will get 2x cubed minus 6x squared. Put everything in parentheses and subtract. Now, these cancel. And then minus and minus gives a plus. So it becomes 3x squared. And I drop down 11x. So now, I ask myself again, how many times x goes into 3x squared? I can do it on the side, 3x squared divided by x. These guys cancel, and I have positive 3x. All right, positive 3x. So what I do now is I multiply 3x back. I get 3x squared minus 9x. Put in parentheses and subtract again. These cancel, and I have negative 11x. Minus and minus gives you plus 9x, which is negative 2x, and I bring down 7. X goes into negative 2x negative 2 times. Negative 2 times x is negative 2x, and then positive 6. Put in parentheses and subtract. These will cancel, and then 7 minus 6 is 1, which is what you write as plus 1 over x minus 3.
So it's minus 3.
Yes. And that will be the end of the problem.
So it's a negative on the, like, so it became negative 2, so that's how you determine that you multiply by negative.
Multiply by negative, what do you mean? You always subtract, right?
No. I'm talking about, like, you put the 2x squared plus 3x minus 2. So the way you determine that it's minus 2 is because it came out with negative 2x down there.
Ah, over here, yes.
Right?
Yes.
How are you getting, on the first part we're dividing, negative 6x squared? I'm getting
Because it's a negative 3.
Negative 3 times 2x
okay, so
is negative 6. Are we good on this? All right, now let's take a look at another example from homework. Here we go. So we want to divide x minus 4 into 4x to the 4 minus 4x squared plus 6x.
When we miss one, when we miss
Placeholder.
what?
Placeholder. So, Dalton, right?
Yeah.
So Dalton already figured out that this particular problem is missing certain terms. And he remembers that something has to be done because of that. Let's see what you guys come up with. You should know this from your previous course. I still have to vote, man. I'll be right back.
Adding x to the zero. You just put it in zero. Oh, wait, that's zero.
I don't want to know what you're talking about.
I know it is. It's just.
But it's like zero. Well, I didn't. I just did x for third. So zero. That makes it.
So what was the secret? What do we put in? 0x cubed. So we put those we called placeholders. So we write it as x minus 4, 4x to the 4, plus 0x cubed. So that's the one.
Why did 0x still not regular x cubed?
Because there are no x cubes. 0 times, right? If you just put x cubed, then that's 1 times x cubed, and you have x cubed. But in this case, there's no x cubed, which means 0 times. All right, let's go. X goes into 4x, 4x cubed. So we have 16x cubed minus 4x squared. So that goes plus 16x squared. That's 16x cubed when you multiply, minus a lot, x squared. Then we subtract again. That's going to be plus, so that's 60x squared plus 6x, which gives us plus 60x. And then we multiply back into 60x squared minus 240x. And then we subtract again, these cancel. And then I have 246x. And then x minus 4 goes plus 246 times, which is 246x minus 800, 960, 72.
What?
No. 84. 984?
980. Yes, sir.
All right, good. And then we subtract. And we get 984 positive. So plus 984 divided by x minus 4. So you can see now the entire problem right there.
Big number.
Negative and negative is?
Why?
All right. So all of that you've seen so far is stuff that you were supposed to know by now from previous course, which was division of polynomials. Whether you took that algebra in high school or you took intermediate algebra here, this is the knowledge that you were supposed to have. Now we're going to take a look at something new.
Just scroll up a little bit. I want to check my
A little bit.
so I can check my answer. So up to the beginning of the problem. Perfect.
You're welcome. So the new division that you haven't done so far is called synthetic division. And this one works only in specific case, but this is exactly the case that we need in our next section most of the time. So it would be very beneficial for you to learn this. It's a pattern which you sit down and you practice until you get it. That's simply what it is. You can find many videos on YouTube explaining how this synthetic division is done. It is very important right at the beginning to understand that this only works if you are dividing a linear term into a polynomial of some sort. So it only works if you are dividing by a linear term. Here I write that in blood. Maybe I should scream that. There we go. All right. So earlier, we had the problem which said we can do this problem or maybe something shorter. How about this problem? Yeah, whatever. We can make up a new problem. So how do we divide x plus 2 into x cubed minus 8x squared plus 4x minus 9? So how do we divide this? Well, we know that we would go x into x cubed goes and go from there. But there is this other way, synthetic division, where you take the root of x plus 2, which is negative 2, and then the numbers are just coefficients of your polynomial. So observe that 1, negative 8, positive 4, and negative 9 are all coefficients inside your polynomial. I am taking 1, negative 8, positive 4, and negative 9.
But where'd you get the negative 2?
It's the root of x plus 2. So if x plus 2 is equal to 0, then x is negative 2. Now some students like to remember it as always the opposite sign of what you see there. It works. It doesn't really give you the reason. So now we know how to come up with negative 2, 1, negative 8, 4, and negative 9. And now we need to learn the synthetic division. I will highly suggest you don't right now, you just observe, because this is done before you even think it. Look, just look. Drop down 1. Negative 2 times 1 is negative 2. Add them down to negative 10. Negative 2 times negative 10 is 20. Add them together to 24. Negative 2 times this is negative 48. And then this becomes negative 57 when you add. We're done. We can translate this quickly into the answer that we want to see, which is x squared minus 10x plus 24 minus 57 over x plus 2. This is how fast synthetic division is. Now I will explain all of this from scratch. Just pay attention to the pattern. So negative 2 comes from here. It will always be the opposite sign of whatever is given here. First of all, synthetic division works only if this is linear terms. If you have x squared over here, or x cubed, or anything other than single x, done, through the window. Can't be done. So it's only for the linear terms. So you have x, and you put -2 there because it was positive, now it's negative, and here's y, if you want to know. Coefficients, 1, -8, +4, -9. There they are. And now here's the way it's done. Drop this one down, multiply by -2, add, multiply by -2, add, multiply by -2, add. Done. Yes? Because they are not the Yes. What happened? Well, I never seen it till I started teaching this. I never seen this one. Because we drill so much on the regular division of polynomials that you actually do it without writing anything down. So,
You're just that smart.
no, there's nothing to do with smartness. It's the drill. It's the exercise. Smartness has nothing to do. It's just how many questions you do. That's all it is. That's all it is. Let's see, can we find something else awful? Plenty. No, you're gonna love this. Look at this. You don't know that. X to the 5 plus 4x to the 4th minus 3x squared plus 2x plus 3 divided by x minus 3. So how about you just set it up? I'll walk around just to take a look at the setup. So I want you to set up the synthetic division. Don't solve it yet. I just have to. Yeah, x to the 5 is.
How can you do that if there's no?
Yeah.
How can you do it if there's no?
Write it down. I gotta go around it. Nice. So far. I see a lot of erase marks. There we go. Good one. Aha. Good.
So they just hear that all day.
Is that last?
Plus 3.
Oh, we got it. Nice. And
Oh, it's in the wrong spot. No. I said wait until you do. All right, so A lot of you, which is awesome, figured out that you have to have the placeholder between 4 and -3. There has to be a 0 entry in the matrix of numbers. So you have to go +3 in a little box, right? +3, and then you go 1, 4, 0, -3, 2, 3. And then you execute the pattern. One, 4, 0, -3, 2, 3. X minus 3 equals to 0. X is equal to +3. 3 is the root.
Well, you're like, when you get the numbers, when you're setting it up, you use the sign of the numbers that you got at the very bottom. It's not
Yes.
the same sign as what we're dividing, correct?
Yeah, +1, +4, -3.
No. Like once you do the multiplication.
What do you mean? Whatever the calculation gives us, we have to follow.
So since all of these are positive, they're all going to be positive.
Yes.
Okay.
So drop down 1, 3, 7, 21, 21, 63, 60, 180, 178, 300, 534.
Wait. When it be 182? 182.
What happened?
21, 3 times 7 is 21.
Yeah, I have that.
It's 2 and 180. It's 182. Subtract it.
No, you add. Zero
You
plus
checked mine wrong. You told me I had it in the right spot.
Okay. So that's 300 and then another 240 and then another 6. 546. Which is 549. Is that good? So, what is the polynomial? It is x to the 4th plus 7x cubed plus 21x squared plus 60x plus 182 plus 549 divided by x minus 3. So I'm going to box off at the end this one. That's your remainder. Always. Observe that you start with x to the 5, but over here you start with x to the 4th, one exponent less because you are taking away one when you divide. Yes?
So is your remainder, is that negative? Is that what you
No, it's just a minus here. It will be a minus 549 over. All right, one more, and then we are going to do the rest of the lecture. Lecture.
But what are we doing right now?
First part of the lecture. Second, third, let's say. X squared minus 5x minus 5x cubed plus x to the fourth, and then 5 plus x.
We have to put it in the correct order.
Do we all have the same answer?
Yep.
So next we have two theorems
What?
that you should know. One of them will greatly reduce your calculations in the next section. So you should definitely study this one. And it's called the remainder theorem. And it states, if the polynomial f of x is divided by x minus c, then the remainder is f of c. This is going to greatly reduce your calculations in the next section. You should know this. It doesn't look so important right now, but it can give you minutes and minutes of precious times on a test, so you don't have to go crazy and worry about certain calculations. So let's take a look at the example. Find the remainder for 3x cubed plus 4x squared minus 5x plus 3 after division by x plus 4.
Something bad happened.
You just couldn't wait.
There was a fire over on 78. There was a fire in the bedroom. Yeah. It is what it is.
Hmm?
I don't think you'll reach anyone except those. They really just
So we have two ways to determine the remainder after division by x plus 4. One way is to actually divide and then take a look what it is, or the other one is just to simply compute it as f of negative 4. So let's first divide because we can. That's negative 12, negative 8, positive 32, 27. That's a lot. Yeah, that's 108, negative 108. And then negative 105, right? So remainder should be negative 105. Now let's see if we compute f of negative 4. We get 3 times negative 4 cubed plus 4 times negative 3 squared minus 5 times negative 4 plus 3. Okay, so 4 times 4, so that's negative 64, negative 180, 192. 16 plus 60, yes?
What is the purpose of putting those, like these brackets next to -4 and the one side on the bottom? That's like the beginning of the,
Which ones?
the one that's in the purple and the black. Yeah, that one, and then the one on top left. What's the purpose of putting those?
This one?
Yeah.
Just to box off so you don't confuse the number you're dividing by with other numbers. And the bottom one is just I'm breaking off which one is the remainder. There you go. Awesome. That's the remainder theorem. You don't actually have to divide. You don't actually have to divide. What you can do is you can compute f at that root, and then you will get the same value. Now, I will be talking about this again next class when we actually put it to use. So I'm just going to now go and talk about the other theorem, which is the factor theorem. And this one is insanely important. So I'm going to consolidate both parts that are given in a book in one and use the mathematical phrase if and only if. So it says like this: f of c equals 0 if and only if x minus c is a factor of f of x. And this is mathematical theorem. If and only if means it works both ways. If one is true, the other one is true, and if the first is true, the second one is true. If the second is true, the first one is true. What does this mean? Well, I would like to explain the factor theorem first using basic numbers, and then we're going to talk about others. So let's divide 3 into 4,302. Now, I'm going to tell you right off the bat, without doing any work, that this 3 is a factor of 4,302. And the reason is because it is divisible evenly and the remainder is 0. Okay? So the reason why 3 is called a factor of this number 4,302 is because it is divisible evenly. There is no remainder. And that's what it means by this. If you get a 0 remainder, right, we know that if you plug in the value of dividing by and you get the remainder on this side, if the remainder is 0, that means that it's divisible evenly, and those numbers we call factors. So x minus c as a term is a factor of f of x because there was no remainder. So in this case here, when I do this division, it's going to divide evenly, and then this 3 is something that I'm going to call a factor. So let's do this division. It's going to go once, then the 3 subtract, you get 13, that's 12, so it's 4, and it's going to give me 12, and it's 1, and it's 10, and it's 3, it's 9, and then it's again 12, and there you go, it's 4, and we're done. So 1,434, no remainder, which means 3 is a factor. So whenever it divides evenly, those numbers are called factors. Now we extend that into polynomials, and every time when it divides evenly, you will have a factor. So let's say you are dividing x minus 3 into x squared plus 9x plus 18. So x goes into x squared x times, multiply it back, that's going to be x squared minus 3x, and then subtract, that becomes, these guys cancel, minus and minus is plus, so 12x plus 18. I didn't get it. And then x goes into this plus 12 times, and 12 times x is 12x minus 36. When you subtract it, you will have the remainder of 54. I'm going to jump into homework and hopefully find a whole bunch of these that you can.
So that one doesn't work.
It doesn't work. Yep. Next class, we are going to talk a lot about zeros of polynomials. All right, try this one. So what do we know about x minus 3? It's a factor. And then 3 is a root or a 0. So this is what we are going to need for next class a lot. So this kind of skill. So we can do the synthetic division as 3 into 1 to negative 15, right? And you can come up with a division and see that the remainder is 0. So it goes 1, 3, gives me 5, and then gives me 15. And look, remainder is 0. Because we have a 0 there, that means that x minus 3 is a factor. And x equals 3 is a root. In previous case, you did not have that. X minus 3 in a previous problem was not a factor, and 3 was not a root. Now, if you want to skip this calculation here, you already know that you are supposed to check at 3, you can just do f of 3 instead of doing all this work down there. So that's going to be 3 squared plus 2 times 3 minus 15, and you see that it's 9 plus 6 minus 15 is equal to 0, which again tells you that the remainder is 0 by the remainder theorem. So over here, I checked if this was a factor by synthetic division, and I also checked if this is a factor by using the factor theorem. Sorry, remainder theorem. So either one of those two would work. I think this one would be a little bit faster if you are good with computing, but then this one might be faster for you. I don't care which one you use, right? But tomorrow, not tomorrow, on Thursday, we are going to use this a lot to find all factors and all zeros of the polynomial. Because if you have a method to find the first one, which is the problem we're going to do now, right? Now it's going to the next problem, the first root is going to be given to us, and we'll have to find the other ones. However, on Thursday, none of the roots will be given to us. We will actually have a different, we'll have a technique that you could use to figure out the first one and then pick up with what we're going to do right now. So right now, the problem will stay this. And guys, you really need to be able to do this because 2 sections depend on this. And then a lot of later work too. It says, find all zeros for polynomial x cubed minus 2x squared minus x plus 2 if you're dividing it by x plus 1. So if one root is -1. So you know that one root is -1. And you will know that tomorrow. You will have not tomorrow, Thursday. You will have a whole list of possible roots and you'll be checking all of them. So now, how do I do this? Well, I know that one root is -1. So I will do this synthetic division right away. And as you can see, synthetic division confirms. Synthetic division confirms that it is a 0 there for the remainder, which means that x plus 1 is a factor and x equals -1 is a root. So both of these are confirmed just because of that 0 in the lower right corner. Okay, so that's one part. And then the next part is now this line is x squared minus 3x plus 2. And you can factor this further. If you can't factor, you can use quadratic equation. It doesn't matter, but you have to get the other 2 roots out of this. So is this factorable easily? Yep. No. It is -1, -2. Right? So x equals 1 and x equals 2. Roots also. So now, what do we have? We have 3 roots, and this is extremely important to make this connection right now, because I don't want to really see some really ridiculous answers on exam and so on trying to come up with new mathematics. This over here is the 3rd degree. third degree polynomial is going to have 3 roots. Now, 2 might be complex, but that's okay, complex numbers. It must have 3 roots because it was the third exponent. So maybe you want to make that note in your notes right now, or on the cover, or tattoo on your arm, I don't care. The fact here is that the degree of the polynomial, which is the degree of the leading term, tells you how many roots you have, exactly how many roots you have. So, because it was x cubed, it was a third, power was 3, exponent was 3, that means you must have 3 roots. Now, we were given 1, because we still don't know how to find the first one. So we were given 1. And then through the means of division, hopefully synthetic because it's the fastest, we obtain the polynomial of the second degree. And the second degree now, since it's the highest exponent 2, must have 2 roots, which could be both real or both complex. Well, we came up with the 2 real roots, 1 and 2. Now what you have is you have 3 roots because you had 3 exponents, and you just have to be a little bit careful of what the question is asking you to do. If the question is asking you to figure out the roots, you just write what the roots are. So 3 roots, and those are x equals -1, 1, 2. So those are the 3 roots. But most of the time, the question is to factor the polynomial, because this is what you're going to need for calculus. You will have to set it equal to 0 and solve the polynomial, so you want it in a factored form. So what are the factors? The factors are x plus 1, x minus 1, and x minus 2. Those are factors. So if the problem says, what are the roots, what are all of the roots, your answer would be this. If it says factor the polynomial, the answer is that. The answer will never stop here in the middle of this word. The answer is one or the other, depending on what the problem is asking you to do. Yes?
It's only off of the leading term.
Leading term, and now you have the complete picture of what the leading term tells you. Gives you A, which way end behavior goes, right? Gives you the power, odd or even, so you know whether both look together or opposite. And it also, the exponent, the number that you have, tells you how many roots you have. So there are 3 features that are hidden in the leading term, and the leading term is always the term that has the greatest exponent in the polynomial. Yes?
And that's what you base the roots off, not any of the other terms?
None of the other terms. No, that's just the leading term. And you have to be careful, because that leading term could be buried somewhere in the middle or at the end. So your job is to locate the term with the highest exponent, look at that one as the leading term, and once you have that as the leading term, figure out how many roots, what's the end behavior, and all of the other cool stuff that you can. And then you can sketch the graph of it. See you Thursday. We'll do more. And bye stream.